Last night, you probably slept 6 hours and told yourself you'd catch up on the weekend. You won't. Sleep debt doesn't reverse like that. By Friday, your brain is performing like someone who hasn't slept for 24 hours, and you won't even realize it. Sleep science is one of the most misrepresented fields in popular health. Not because the research is unclear, it's exceptionally clear. Because the myths are more convenient than the facts. We think of sleep as passive, a pause between days. Biology disagrees fundamentally. Sleep is one of the most metabolically active states the human body enters. Every major system, neurological, immune, hormonal, cardiovascular, runs processes during sleep that cannot occur while you're conscious. The brain doesn't downshift, it switches modes entirely. What we lose when we cut sleep short isn't just energy for the next morning. It's cognitive precision, immune competence, hormonal regulation, and the brain's ability to consolidate everything we experienced during the day. Most people losing those things have no idea it's happening. And the more sleep debt accumulates, the harder it becomes to detect. The most widespread belief about sleep is also the most dangerous, that you can run a deficit during the week and repay it on the weekend. A 2019 study published in Current Biology tested this directly. Subjects were divided into 3 groups over 3 weeks. The first slept 9 hours nightly, the second slept 6 hours nightly. The third slept 6 hours on weekdays and recovered with unrestricted weekend sleep. By week 3, the weekend recovery group showed no meaningful improvement in metabolic markers compared to the chronic short sleepers. Caloric intake remained elevated. Insulin sensitivity remained impaired. Weight gain continued at the same rate. The weekend sleep had not reversed the physiological damage accumulated Monday through Friday. The second finding was subtler and more alarming. By day 11, subjects in the sleep-restricted groups had lost the ability to accurately assess how impaired they were. They rated their own alertness as near normal, while their measured cognitive performance continued to decline. The gap between perceived function and actual function widened daily, and they couldn't detect it. Sleep debt is designed to conceal itself. The more you accumulate, the less equipped you are to recognize it. You stop noticing the performance gap right when the gap becomes most consequential. This explains why catch-up sleep feels so effective. After a 10-hour Saturday, you feel dramatically better. That feeling reflects partial recovery, not full biological restoration. Sleep debt is invisible by design and compounds without announcing itself. But the number driving every piece of sleep advice you've ever received, 8 hours, was never established from sleep biology to begin with. 8 hours is treated as a universal biological requirement. It was standardized as an industrial efficiency metric. The guideline took hold in the mid-20th century through labor scheduling research, studies designed to establish minimum sleep thresholds for maintaining factory worker output, not to understand human sleep physiology. That number migrated into health guidelines without clinical validation as a biological prescription. Sleep need is genetically variable. Research from the University of California identified a mutation in the ADRB1 gene that allows a small subset of the population to function optimally on 6 hours per night without measurable cognitive impairment. Another subset genuinely requires 9 or more. The clinical range is 7 to 9 hours, but that's a population average, not an individual prescription. What matters more than total hours is sleep architecture, the internal structure of each sleep cycle. One complete cycle runs approximately 90 minutes and moves through 3 distinct stages: light sleep, slow wave deep sleep, and REM. Each stage performs separate biological functions. A healthy night contains 4 to 6 complete cycles. Waking mid-cycle, particularly when an alarm pulls you out of slow wave sleep, produces sleep inertia, the heavy, disoriented, cognitively blunted state most people blame on not sleeping enough. In many cases, the problem isn't quantity, it's the point of interruption. Waking naturally at the end of a cycle, even at fewer total hours, produces measurably clearer cognitive function than being pulled out of deep sleep by an alarm. The total number is a rough guide. The structure is where the biology lives. The number of hours matters less than most people assume. What's happening inside those hours, the active maintenance your brain runs while you're unconscious, is what no one ever fully explains. While you're unconscious, the brain runs three critical maintenance processes that are physiologically impossible during waking life. The first is waste clearance. The glymphatic system, a network of channels surrounding the brain's blood vessels, becomes nearly 10 times more active during sleep than during waking hours. Its function is to flush metabolic byproducts that accumulate through conscious neural activity. One of the primary substances it clears is amyloid beta, the protein that aggregates into plaques associated with Alzheimer's disease. Chronic sleep restriction has been directly linked to accelerated amyloid accumulation. This clearance requires the brain to be offline. It cannot run alongside conscious thought. The second is memory consolidation. During slow wave and REM sleep, the hippocampus transfers newly encoded information into long-term cortical storage, stabilizing motor patterns, language acquisition, and problem-solving pathways. A Harvard Medical School study found that subjects who slept after an initial learning session retained significantly more than subjects who stayed awake for additional practice. More practice produced less retention than the sleep that followed the first session. The brain encodes during the day. It files at night. The third is immune maintenance. During deep sleep, cytokine production increases significantly. Cytokines are proteins that coordinate the immune response to infection and inflammation. A single night of sleep, restricted to under 4 hours, has been shown to reduce natural killer cell activity, the cells responsible for destroying malignant and virally infected cells, by 70%. One night, 70% reduction. These three processes run simultaneously during sleep. None of them have a daytime equivalent. You cannot substitute them with rest, meditation, or recovery protocols. They require the brain to be in sleep state. Your brain clears its own waste, files your memories, and defends your body, all while you're unconscious. The question isn't whether cutting sleep matters, it's why the performance cost has remained so invisible despite being one of the most documented findings in modern neuroscience. The cultural narrative around sleep deprivation has always framed it as a calculated trade: sacrifice sleep, gain time, produce more. The research dismantles that arithmetic completely. A University of Pennsylvania study placed subjects on 6 hours of sleep per night for 2 consecutive weeks, a schedule millions of people maintain as normal. By the end point, their cognitive scores across response time, working memory, and decision accuracy had declined to the equivalent of subjects who had been awake for 24 consecutive hours. They had reached the cognitive floor of total sleep deprivation, gradually, without a single all-nighter. The subjects rated themselves as only slightly sleepy. That self-rating gap is the core problem. Gradual impairment doesn't register as impairment, it registers as your new normal. The baseline recalibrates downward, and the reference point for sharp disappears entirely. The Rand Corporation estimated sleep deprivation costs the United States $411 billion annually through workplace errors, accidents, reduced output, and increased healthcare utilization. That is not a wellness projection. It is economic modeling built on productivity data. You cannot sustain output by compressing the biological process that repairs the machine generating that output. Every hour of productive work runs on the maintenance completed the night before. The pattern here matches every myth we've broken down on this channel. A complex biological system gets oversimplified, a convenient shortcut gets normalized, and the actual mechanism gets ignored until the cost becomes undeniable. Sleep is not rest. It is a distinct mode of biological operation that handles functions waking life cannot perform. Cut it short and you don't just feel tired the next morning. You think slower, retain less, make worse decisions, and defend against illness with a fraction of your immune capacity, all while feeling roughly normal because the baseline has already shifted. The most powerful change isn't adding one more hour this week. It's removing "I'll sleep when I'm dead" from your operating philosophy entirely. Which of these changed the way you think about your own sleep? Drop it in the comments. I read everyone. If these invisible systems fascinate you, there's one more worth watching. The data showing how your height silently shapes your income, your career trajectory, and the unconscious decisions other people make about you before you've said a single word is right here. Height determines your paycheck. Here is why. The connection between the two is closer than you think. I'm Capsule Explains. Until next time.